Hello everyone, I hope you all are doing very well. And in this AI interview preparation series, this is the question number 7 that we are going to discuss here. That is, explain the bias variance trade-off in machine learning. What is bias variance trade-off? Important question to learn. Basically, bias variance trade-off, it is a fundamental concept in machine learning that will help us in understanding the managing performance of a model. Means your model, it should not be oversimplistic as well as it should not be over complex, but it should be simple as well as able to understand complex features. So how to make a balance between such kind of things, that is between bias and variance, that is a kind of thing that is bias and variance trade-off called, right? Now let's break it down into step by step. First we are going to discuss bias. So what is bias actually? Bias refers to the simplifying the assumptions. We are having some assumptions and we are simplifying it by making the model such that target function easier to approximate. High bias means model is overly simplistic and it fails to capture the underlying pattern of the data. Example, a linear model is trying to fit a non-linear data set. Obviously, if linear model will capture non-linear data set, then many of the features will not be count here. So it will have high bias because it cannot represent the complexity of the non-linear data because we are having linear model. So we need non-linear model in that case. But if we are applying linear model means definitely high bias will be there. So if we are simplifying the assumptions so that the target function become easy to approximate, it is a bias, right? The other thing is variance. Variance is basically model's sensitivity to small fluctuations, that how easily one model can fluctuate on small changes. So high variance means model is overly complex and it captures noise in the training data as well as rather than the underlying pattern. So what will happen in that case? It will show a great quality of accuracy in the training data, but whenever a new data will come, it will be poorly respond in that case. That is overfitting condition. So high degree polynomial model that fits the training data perfectly but performs poorly on unseen data due to overfitting. That is because of variance. So variance is model sensitivity, right? That how our model sense the data. If model is overly complex, it means that it will capture other details, noise in the data also, which is not required, right? And the trade-off. So basically the bias variance trade-off illustrate relationship between model's complexity and generalization performance. So if we are going to increase model's complexity means we are adding more features to increase polynomial degree. What it will give? It will reduce bias. Why? Because we are having more complex data. We are having more features. So obviously bias will not be there, but it will increase variance. On the other hand, conversely, if we are reducing models complexity means we are reducing features, we are only considering only few features, so it will increase bias but it will decrease variance. You can understand it like, let's say election is going on. So if we are surveying on only small people of data, that is the features of peoples are only from the one area, or it could be one religion, or it could be one you can say the caste, or one any particular area. So it means that only few features. So few features means result would be biased. On the other hand, if we are considering more features, means public is more, different caste, different religions, different area, different geography, and different peoples we are taking means more features. So obviously it would have less bias, but variance will be more. Variance will be more means a small change in the data people, a small change in the data set will increase sensitive to the results output. Getting it? So low features, small features means more biased because it will be biased in one way because we are having low data set. But on the other hand, if we are having higher data set, more features mean bias will not be there. Large data set, less bias. Less data set, more bias. If more bias, less variance. If higher variance, then less bias. Getting it? Okay. So what is the goal here? Goal is to find the balance. So the goal is to find the right balance between bias and variance, just like mean squared error on unseen data or test data. So underfitting occurs when the model is too simple, that results in poor performance on both training and testing data. So on both training and testing, if our results are poor, that is underfitting condition. That is model is too simple. On the other hand, overfitting means model is too complex. High variance means it is performing well on training data but poorly on the testing data. Thus, we can conclude a well-balanced model generalize well to unseen data, achieving low bias and low variance. So what is the final goal? Model evaluation. It is the final goal of bias variance trade-off, right? So techniques like cross-validation can help in evaluating models' performance by estimating both bias and variance. So learning curves which plot training and validation error against the model's complexity can also provide insights into the bias variance trade-off, right? So bias variance trade-off highlights the delicate balance between model simplicity and complexity. Understanding the trade-off is crucial for building machine learning models that generalize well to the new and unseen data. I hope the question that we have discussed here is clear. Please subscribe this channel in order to get more such videos. Have a very nice day, guys. Jai Hind, Jai Bharat.